Okay.
Okay, now it's the interior, from -5 to 4 interior, so we're not gonna include the endpoints of -5 and 4. We are, however, gonna include all the critical numbers on the inside. So my critical numbers are, when t is equal to, I see -4, 1, and 3. Now I have to determine which of those is going to be the maxes. Now, what about -4, max or min?
-4.
Looking at the picture. Alright, looking at the picture. This is a picture of F, right? But we need to look at G's critical numbers, which come from G's derivatives, which is F. To the left of -4 is F positive or negative?
Negative.
And to the right?
Positive, so.
So that would be a min, okay, not a max.
No.
What about 1? To the left and to the right?
They're both, it does, it's not really.
So it came up, and then instead of turning around, it went up some more. So not a max, not a min.
Faked you out.
What about 3?
It's a max.
Max, because you go from positive to negative in the wording. I'll throw this stuff away. There is a max at t equals 3. I think y'all said x. What is x? We switched to g. My bad. Because F, oh, I gotta say something about this too. Some of you said this, the graph. Not good. Because it's not exact, I know there's one picture of a graph here, but you could have drawn another graph somewhere else. If you said the graph of F, that would have been fine, but simply saying the graph, not acceptable. I would have just said F. Changes, yada, 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 positive to negative, you gotta do that. C, find the absolute minimum value, not where it occurs, but what it is. Okay, so to find the absolute minimum, part C. Again, we do all the critical numbers, and we've seen from this that the critical numbers are at -4, 1, and 3. Now, hang on. They are using the open interval, I'm sorry, closed interval, which means the endpoints could have been maxes and mins. -5 is going to be a max because our graph starts at decreasing, so that's out. We already figured out that 1 and 3, 1 was neither and 3 was a max, so that leaves us with -4 as a candidate and +4 as a candidate. So now all I have to do is figure out what the areas are and see which one is actually bigger. All right. Let's see. G of -4 would have been the antiderivative from -3 to -4 of f of t, which is another area question, but this time we're heading backwards. Even though that's above the x-axis, we are heading in a backwards direction, so that area is -1. We just did a little triangle there. If you did g of +4, well, that's a lot of area. That is moving from -3 to, well, okay, here's it's kind of easy. Okay. We already did from -3 to 0, we got this in part A. The stuff from 2 to 4 is going to cancel out, so the positive and the negative will cancel each other out. So all I need to know is what's underneath that circle, and that's really just a semicircle minus, or a rectangle minus a semicircle, which is going to end up being 2 minus pi halves. So the final answer for this one was 13 minus pi over 2. Wouldn't expect y'all to come up with that quickly, but the math is there. This is clearly bigger than this. This is about 5, a little bit less than 5. That's -1, so the min is -1 at x equals -4. And then last but not least, find all the values of x at which you have a point of inflection. All I need is for this, the slopes to change from positive to negative, or just change signs, negative to positive. So if I look at F changes direction. By the way, F's direction change, his first derivative is the same as G's second derivative, which would give us concavity. That's gonna happen at -3. 0 is a red herring, that one doesn't change directions, it's heading down and down again. 1, it does change, and then 2, it changes. And then last but not least, one more time, last but not least, number 6, almost done with you people. All right. I forgot to change the date too, I apologize. Oh, I did. Did it this time? What's the date? Wednesday? It's mid-August. Sorry for that. I know it's been bothering a lot of you.
Uh-huh.
Consider the differential equation dy dx is equal to x squared times y minus 1. And you are, okay, slope field. We're gonna party. I do love a slope field. What do we have? 4, okay, so 1, 2, 3, we got these dots, and then one to the left and one to the right. Okay, because having an x value that is 0 would give you 0 slopes, you have horizontal tangents all along in here. And because having a y value that is 1 would give you 0 slopes, you have this right here. So this little upside down cross. And then if you plug in numbers, I think these end up being -1. And these end up being +1. And these end up being like +2, I think, something like that. So there's your slope field. Thought that was pretty easy. Part B, it says, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all the points for which the slopes are positive. Okay, first off, the x thing is never going to give me a negative, so we don't need to worry about him. The question is what happens to make him positive. He needs to be bigger than 1.
Yeah.
At the same time, in order to ensure that it's positive, we need to make sure that this is not 0. So we have to have this added stipulation that x cannot be equal to 0. That one was pretty straightforward, but some people chose not to get the points for it. And don't know why. Last but certainly not least, separation of variables. Our initial condition, the one they gave us here, is that f of 0 is equal to 3.
Nice.
And from there, find the solution. All right, let's rock and roll.
Wait a second.
Wait a second.
0 equals 3.
F of 0, at the point f of 0
What's-
equals 3. So
what?
at that point right there.
Okay.
I know the slope is going to be
Yeah.
0, but I
Yeah,
also
I
have
know
this
that.
other curve that might be, it looks like it's kind of coming up and maybe doing something like that.
Yeah.
It's weird about this.
That has a horizontal tangent
All right.
out there. Weird thing.
dy dx is equal to x squared times y minus 1. Separate the variables, I'll leave the x squared alone, I'm gonna bring the y minus 1 over here. And that's gonna be x squared dx. Antiderivative, if you don't recognize that as a natural log by now, or brain dead, 1/3 x cubed plus c. 4 points in under 10 seconds. X. I'm gonna exponentiate, slap an e on that, but, oh, sorry, let's find c. Crazy. All right, so we get natural log of 3 minus 1 is equal to 1/3 times 0 cubed plus c. That one's gone, so we get c equals natural log of 2. Where does that put me? Natural log, absolute value of y minus 1 is equal to 1/3 x cubed plus natural log of 2. Then I will exponentiate, and that gives me absolute value of y minus 1 is equal to e to the 1/3 x cubed plus natural log of 2. I'll split that into e to the natural log of 2 times e to the 1/3 x cubed. These cancel. Absolute value of y minus 1 is equal to 2e to the 1/3 x cubed. The absolute value is going to mean this could have been positive or negative. And then I will bring the 1 over. And then the last question is whether or not my answer should be positive or should be negative. If I stick in 0, I'm supposed to get out 3. If I stick in 0, this is 0, e to the 0 is 1. So is 1 plus 2, 3, or is 1 minus 2, 3?
1.
1 plus 2, so my final answer
Yeah, plus.
is 1 plus 2e to the 1/3 x cubed. These are so easy for us to do by now, hopefully. All right, ladies and gentlemen, looking good. When we come in tomorrow, oh, good, let me show you this, I got you all here. We'll talk about it now. Alright, so all of you are gonna get one of these tomorrow, this is your test booklet. We're gonna do free response tomorrow. Alright, it's easier for me to grade. If I can get your free response done first, while y'all are working on your multiple choice, I can be grading your free response, because the multiple choice is frankly pretty easy. When you take the actual AP, you will do multiple choice first, that's the first part of it, and then you will get to the free response part in the back. I want you to see what the free response looks like. They tend to do this. They'll have some directions up front, which you don't need to worry about, but then they'll give you this. This is what a typical problem looks like. So here's the problem, and then here's where you put A, here's where you put B, here's C, and here's D. So they have it broken up into the 4 sections, 3 sections, or whatever. So it is very difficult for you to put information in the wrong spot. And notice they try and keep it where you can see question 1 throughout the entire problem. So they're pretty nice about that. This is not how you're going to do it. Because I'm going to use these tests year after year, I have a sheet of paper for each of these. So you will do, multiple choice will be on this page when you do it. Calculator, or non-calculator, calculator. And then you'll just have 1 page per problem. Okay, it makes it easier for me to grade this way and I don't have to make extra copies of this test every year. So this will be your test part tomorrow, are the 6 free response questions. We will time it, so it will be exactly 30 minutes for the, I think this is 3 and 3. I think it's 3 and 3, might be 2. Yeah, 2 and 4. So you have 30 minutes with your calculator, and then you'll have an hour without your calculator. And the way they do the AP, instead of taking up the calculator part, you can keep it, you just don't get to use your calculator on it. So after 30 minutes, they'll just take your calculators away, give you 4 new problems, and say, here you go. I would suggest, if you haven't finished the 2 calculator problem, put them aside, be done with it, finish your non-calculator, then come back to it if you want to. But treat these nicely, because I do use them year after year. Okay, that's all I have to say about that. Be ready when you first get in here, we'll do some pleasantries and attendance and things like that. And it will be graded like our usual ones, so an average of 90. It will not go on your third 9 weeks, even though we still have, what, like 2 weeks left in third 9 weeks. This, all of our review stuff, I'm gonna put on fourth 9 weeks, because if I don't, we don't actually have any grades in fourth 9 weeks, because of AP test being so early, yeah. So if you're looking online, you will not find these grades for a while. That's all I have to say about that. Everybody relax, do whatever you want to for the rest of it. Quests are still due Friday, and throughout all of our review stuff, your quest will continue to be due on Friday. Thank y'all, have a good day, see you tomorrow.